Let's look at some of the properties of logarithms. The logarithmic function with base a is the inverse function of the exponential function. Therefore, it makes sense that the properties of exponents should have corresponding properties involving logarithms. Notice here are our properties of exponents. Now you remember they were in a video several videos ago. A to the x times a to the y equals a to the x plus y. A to the x over a to the y equals a to the x minus y. If you're not sure of those, be sure you check them out. Now, let's look at the corresponding properties of logarithms. Notice the log base a of uv is the natural log, is the log base a of u plus the log base a of v. We have a product property, a quotient property, and a power property. You will need those. We rewrite a lot of logarithmic expressions to either simplify them so that they can be used in algebra and calculus. The properties of logarithms can be used to expand expressions, and the process can be reversed to condense logarithmic expressions. We're going to do several examples. The first one will deal with expanding an expression. For example, here I have the log base 10 of 10z. That equals the log base 10 of 10 plus the log base 10 of z. And remember, log base 10 of 10 is 1. Let's do another one. How about the natural log of the cube root of t? We'll rewrite that as the natural log of t to the 1/3, which is 1/3 natural log of t. How about the natural log of xy over z? Okay, using those laws of logarithms, look how that becomes the natural log of x plus the natural log of y minus the natural log of z. Let's expand some more, like the log base 6 of a, b cubed, c squared. So we use our product rule. That gets it out. Then we're going to use our exponent rule so that the log base c of b cubed becomes 3 and 2 times the log base 6 of c. Let's try another one. How about the natural log of x over the square root of x squared plus 1? Now we have to be careful here. Remember, the logarithm of a sum is not defined. So this would be the log of x minus 1/2 the log of x squared plus 1. All right, let's see here what we're doing next. The log of x to the 4th times the square root of y over z to the 5th. And when we're able to expand it this way, there's going to be a part of calculus that this is going to make it really easier to take derivatives than to have to use product rule, quotient rule, chain rule, and all sorts. Now, the last examples involved expanding. Now let's look at condensing them. For example, if I give you the log base 4 of z minus the log base 4 of y, we write that as the log base 4 of z over y. Real easy. Put it back where it came from. Now, 2 log of x. That's going to be the log of x squared plus the log of x plus 1. And that'll be the log of x squared times x plus 1. That works out rather well. Let's see what we want to condense here. Suppose we have 1/3. Oh, look at those square brackets coming up. That means that this one is tricky. That 1/3 is going to get used last. So this will be 1/3 of the log of x plus 3 squared plus the log of x minus the log of x squared minus 1. Now still working in the square brackets, that'll be the log of x plus 3 squared times x over x squared minus 1, and then ultimately this will be the natural log of the cube root of x plus 3 squared times x all over x squared minus 1. And we've condensed several logarithmic expressions there. And so anytime you want to look back, stop the video and go back. Now, we can also use these properties to evaluate logarithms without using a calculator. How do we do that? Well, look what we did when we expanded. We know the log base 6 of 6 is 1, so that comes out 1/3. How about log base 2 of minus 4? Ah, not possible. I cannot find the logarithm of a negative number. All right, let's try another one here. Natural log of e cubed minus the natural log of e to the 7th is 3 minus 7. Do you remember why? Go back and look at your rules if you don't. Natural log of e to the 4.5 is simply 4.5. Learn that. That's going to be really important. Log base 4 of 2 plus the log base 4 of 32 is the log base 4 of 2 times 32 is the log base 4 of, what are we going to get here? 64. Okay, and we know that's 4 cubed, so that will equal 3.